or pound.
Okay, the conference was able to dial in as well.
Yeah, okay, so I guess it's just about okay. So we're ready to go. So you got the recorded thing going?
I've got it recording now also.
Okay. So before Eddie starts off, there is a chat box on the right-hand side, little tab beside the 17 number of people participating, blinking or something, and you can send messages. And now I'm going to be looking at that while Eddie deals with the presentation. So if there are issues, I'll try to do that offline. Unless there's stuff that he needs to do. And do remember to choose the recipients as all, so that we all can see it, unless it particularly is for me or another person. So choose the all in the drop down, and then type the text and click send. Okay. So with that, Eddie, you have about 50 minutes. Let's go.
Okay. Well, the first thing I'm going to do, I'm going to take that link that's here in the welcome screen and just paste it into the chat, so you've got a link. Those of you who don't know the TDI Users Forum, I suggest that you become familiar with it. It's a great place to search, and it's Google, so it shows up in your Google searches as well. And with that, I'll start sharing my screen. All right. And everybody should now be able to see my TDI and my assembly line. And I'll tell you what, I'm going to go back to the meeting room, and there's a little button where you can raise your hand someplace. There's a button for raising your hand. So if you can see the screen, or if you're having problems, then raise your hand and put something in the chat box. Also, if the resolution is so high or too small that you can't see the letters or the lettering and stuff, let me know, and I'll just bring down the resolution. Okay. Right, as Johan said, the debugger is an absolutely invaluable helper in both building, testing, debugging your solutions. And I've got my demo assembly line up here. This one is reading from a DB2 database, and then doing some lookups from an LDAP. And I have an on-no match in case something's not found, in which case I just print something. This bit right here is not being executed because I do a skip entry before that. And then I check to see if the mail attribute that I'm getting in from my LDAP is valid by checking to see if it contains an @ symbol or not. And if it doesn't, then I'm printing a message, and I'm clearing all the attributes from work.mail. And then finally, I'm writing this stuff out to an XML file. And as part of that, the mail attribute, I am grabbing the full name and creating a new mail attribute value. Dropping that into the work entry, the work entry mail attribute, and returning that as my map. So are there any questions about what the assembly line is doing? Anything that you guys wanted to talk about just the assembly line for a moment? I can't hear anything. Okay. Are you guys hearing, everybody else is hearing me?
Hey, Eddie.
Yes.
Hey, this is Bolly. I cannot get to the web conference for some reason. Is it working fine or?
Yeah, we've got 18 people in right now.
Okay.
You just keep trying, okay? Okay. So then, now to start the debugger, we have this debugger button. And in 7.1.1, until you get to Fixpack 6, I believe it is, every time you hit the debugger button, the first time for an assembly line, it brings you into the data stepper. Let me just show you that. if I can find my data stepper button. All right, and it's not going to let me do that. And with the data stepper is that you don't have a complete outline of your assembly line here. And you have a button over to the, oh, there it is. I'm sorry, there's my data stepper button. So this is what you get with the data stepper. So when you hit the debugger, if you end up like this, then you're in the little brother of the debugger, you're in the data stepper, which allows you to step from connector to connector and look to see what's in the con entry. So what's being read in before a map, input map, and what's been mapped out from an output map before it's written. The full debugger gives you these as well, but it gives you a lot more. All right? This is one way to start the debugger. Another way to do it is to simply say where I want it to stop. So let's say I want it to stop on the on-no match. I can right-click on it and say run to this point, run and break here. And that'll launch the debugger, run the assembly line to that point. Okay, so I'm going to just stop this again and restart it, and we'll take it from the top. So the debugger, here on the left at the top here, it gives me some step buttons. I can step into, that means I want to step into hooks, or I want to step into the script of a hook or an attribute map or a script component. And if you've got noise in the background, please go on mute. Then I've got to step over. Step over takes me from component to component. Now it will go inside my branches. And then the continue button will run until it's completed or until I hit a breakpoint. And we'll talk about breakpoints in just a moment. And then I have the stop button, so I can stop this at any time and restart it. And that loads a fresh copy of the assembly line that I'm working on that I loaded into the debugger originally. Then I've got a button to remove all the breakpoints. And a breakpoint I can easily set here by just clicking at this point on these little checkboxes next to each component in my assembly line. So again, if I wanted to run to the on-no match, I can set a breakpoint and I can press continue. And just as we did from the assembly line itself, I can also right-click at any point and say run and break here. And that works as a temporary breakpoint. And it turns everything else off. So even if I have other breakpoints, it will run to that point before it gives me control again. In the middle part, we have each connector with its con entry being shown here. So if we just step now, I'm going to step over. And the first step in an assembly line, because an assembly line goes through 3 phases of its life cycle. It initializes, or it starts up, and at this point, by default, all the connectors initialize. Then we go into cycle mode. And then finally, we have when the assembly line stops and all the connections close. If I press a step over, it's going to initialize all my connectors and start the first cycle. If I step into, I begin stepping into each of the hooks. I'm confident all of you know what hook flow is. We have a number of hooks for each connector for the various modes and for function components. And the assembly line has hooks as well. So I have before connectors initialize, and then each of the connectors goes through its initialization. Then I have the prologue after in it. Then the cycling starts, and I have a hook at the top of each cycle. I can see these in the debugger. And in that way, the debugger is a very good way of actually walking through your assembly line and seeing exactly what's happening. Where is the flow going? Am I finding stuff, not finding stuff, or finding multiple? I can walk through this and actually then query the data, look at the data and make changes if I want to. Out to the right-hand side here, I have a watch list. So by default, I've got work, I've got con, and I've got all the global variables that are defined. So these are the ones that are built into TDI, plus the ones I define. So I'm going to use one step over and go to the top of the first cycle. So now the people connector is about to read the first thing from its result set. These are the global variables I have defined. And this includes any script variables I've defined as well. So here we can see we've got task, which we use for task log message. We can see even which Java class this is. So we can go into our Java docs, take a look at the assembly line class, and figure out what task can do for us. The same thing with system, session, and whatever. And once I step over this next one here, we can see that we've read in 4 attributes. Now my input map is relatively straightforward here. I'm just reading these in. Oops, wrong one. I'm just reading these in, but I am renaming birth date to birth day by just clicking in it and then renaming it. So I drag them from the schema and then rename birthday. And that means when I step past my input map, I must have gone to the on-no match, and in the on-no match, I do a skip entry. So what we can do is run to this point. That means we're going to just skip past all the people that it's skipping, and we can even see the message being printed down here because this is the log output at the very bottom. So now we've skipped a few more people, and now we've finally gotten somebody. So as I said, here's the birth date. If we go up here and take a look in my watch list, work contains a birth day, as well as the attributes it read from the LDAP. So in this way, I also can step down to see if a mail is invalid. And my mail invalid was checking to see whether there was an @ symbol in the mail attribute. So this one will be a valid mail. But again, I can go down to my fixed mail and just say run to this point. And now I've gotten a mail address that's not going to be valid. So this allows me actually to walk into all the various different branches on my input data or my data set. As I'm reading through it and processing this, I can walk through and actually see what's happening in my assembly line. I can also set conditions for these. So I could say that I want to stop at this point, but the breakpoint condition I want to set here. And here I can put any snippet of JavaScript that evaluates to true or false. So here I could say work.getString full name. And I'm using getString because I want to make sure that I've got a string here and not just, if I say work.fullname, I'll get an attribute. And I can do a starts with. So if the full name starts with a G, then I want to stop here. I'm going to stop this and run it again, and then continue until I find somebody with a G. And actually, I think I'm going to change that to a J, simply because I'm only reading 25 right now. Let's start this. Okay. And I've gotten the condition on the wrong one. Okay, I'm going to remove this right now, and this is something that I'm not going to confuse you with yet. We'll talk about that afterwards if you have questions. But the idea is that I can set a breakpoint here to say that I want record number 10,000, so I can just let the system run until we get to the point where I know there's a problem, and then start stepping through it. Now, my watch list also allows me to add my own. So I've added a couple here. And here I can add any snippet of JavaScript as my breakpoint. So like I did, I was doing work.getString full name to uppercase. And that's what I'm seeing here in the watch list. Yes.
You just said you could use any JavaScript as your breakpoint. Right now, you mean watch list.
I meant watch list. Sorry. Absolutely right. So I can add new watch list variables here, and I can do things like task, dump entry, work. And the watch list is updated on every step. So that means every time I step now, I'll get a new dump because it executes this and shows me the result. And task dump entry doesn't return any result, so the result or the value here is empty. But I see the result of that expression in my log output. Now, as I mentioned, we step into this. I can now step into scripts as well. So now I'm at the first line of the script. If I make one more step, I'll see the output appear here at the bottom, along with my dump. And I'm about to execute a mail, work.mail.clear. Now, this little innocuous line here that says enter JavaScript expression and hit return is really the star of the debugger in many ways. Because whatever I type here is going to be passed to that assembly line, which is running on my server. And in my case, I just have my local default server. But I could be connected to a server on another platform. So it's going to be or sent to that server and executed as though it were part of the assembly line at that point. So from here, I can do things like work.mail and return the mail attribute. I can also set values if I want to. So I want to change the full name. I could change that to, the bunny. And now if I do a task, dump entry, work, we'll see that the full name has been changed for the data that my assembly line is working with. And this is very significant because even though my input data might not have the values which are going to exercise all the logic of my assembly line, I can make that change dynamically while I'm debugging and make sure that it steps into my branches or into my ifs. And we're looking here at the TDI 7.1.1 version, which means we also have now script libraries, local libraries and functions, and some code snippets that you can drag in. It's not much use here simply because this is read-only. We can only look at the scripts here. If I want to make a change, I have to go back to my assembly line and make that change. Another thing about 7.1.1 that differs from 7.1 is that if I want to stop on a breakpoint, if I want to see a hook here, I enable it, and then it shows up also here. With 7.1.1, if I step into and I have no hooks shown, it's going to actually show me which hook I'm stepping into. So I'm in the Yes.
It's also worth pointing out to you all that there are differences in the capabilities of the debugger when you look at TDI versions. So with 6.1.1, it has one type of debugger, which we're not going to spend any time on ever. We're only going to be spending time on 7.0 and out. Now, with 7.0, we have the Eclipse tooling. 7.1, we did quite a lot with the debugger. In 7.1.1, we've done reasonably little. So 7.1 is really a good place to be because, first of all, it has the ability to walk into the JavaScript code itself, which, of course, is very valuable once you get that far. We might not even get that far today, depending on Eddie. And also, I don't have time for that, Eddie, but, showing people the ability to hook into a server also, from the outside, is a good tool for people to know about.
Okay, well, was there something particularly you thought we should look at now, Johan?
No, not at all. I just wanted to point out the differences of the versions of TDI in case people trying this out at home and not seeing it. It's 80 running 711, right?
7.1 will look exactly the same. If you want to see the various hooks, in addition, you can say, show me all the hooks, as well as showing me all the attribute maps. And then you can step into each of the attribute maps, or run and break at that point. If you've got some code someplace, for example, here in my output, I have an output map where I'm computing the male attribute, and I can run to this point, and then step into it, and then actually see what's happening. So first line, I'm going to define a new variable called name. I'm going to get the full name as a string value. So now I have name here. And another little trick, which is very handy when you're working with data that you're reading from various types of systems, is to do a get class to find out what kind of Java object is this. I'm sure some of you may have been working with stuff like notes or other systems that return custom Java objects to store things, like, for example, dates or timestamps. And once you know what the Java class is, it's relatively simple to take a quick look on the net or pull up the Java docs and see what's available. So in the case of a Java SQL timestamp, which you will be getting from a database, it's relatively simple to convert that to a date with just one line of script. And as we step through this, name has now changed. We've now made it lowercase. We've replaced spaces with dots. And then finally, we add that to work. So if we check the work.male attribute now, we see it has a single value. We do one more step, and it now has multi-values. And this is really the debugger in a nutshell. Let me just remove all my breakpoints. It's really no more complex than this. But of course, mastery comes with practice. And the more you use it, even on simple assembly lines, the deeper understanding you'll be getting of how TDI works. I'm sorry, what? Were you talking to me? Or do we have are we on a group call now with the?
No, I just think somebody didn't notice that they were online. Just keep on going.
Okay. Well, that's really the debugger in a very, very quick run through. Now we have videos on this as well. There's a video that shows you how the debugger works. If we go to YouTube and we look for Tivoli Directory Integrator, then we have a video out on using the debugger, which kind of goes through the same steps that I've done here. So let me push this back to you guys. Questions? Okay, we have people that are having trouble getting into the call. Everybody's really quiet. All right. Let me show you that some of the stuff that I do when I'm working with projects is to make a very simple assembly line, which I call 0, 1 underscore test, just to make sure that it sorts near the top of my list. And in this assembly line, I add an empty script. And then I've got my little debugging playground. So from this point, I can get a chance to play with a lot of the stuff that happens in TDI. So once I've just initialized, just taking one step and initialize the assembly line, so I have a JavaScript engine, I can now start doing stuff here. So if I want to create XML or JSON, or I want to try running parsers or whatever, I can do that here. Now, it's only a one-liner, but it does maintain a history of the stuff I've typed before. If I use arrow down, it shows me the statements that I've done already. And this is personal to this assembly line. And once I have code that works, I simply copy it, I go back to my assembly line, and I paste the code in. Note also that anything I do here, which would normally interrupt the processing of this assembly line, will not do so from the debugger. So if I have a script error, or I get the script error here in the debugger. Let me just make this bigger again. I see the script error here, but it has no effect on my assembly line. So again, it's a safe place to play, even if you're connected to another server. Now, those of you who work with systems like TIM, where you are not executing, you don't have the assembly line in your CE as you're working, in order to get a debugger open, you have to tell the server that you want to catch the next assembly line, which is going to be executed. Let me just show you how that works. So I first have an assembly line, and I'll use this assembly line to start it, or maybe not. I think I'll make a new assembly line. And I'll add an assembly line function component to start 0-1 test. And then the secret here is I begin debugging this assembly line. So now I have a debugger open for this assembly line. And at some point, I'm going to, just remove this, I'm going to execute my other assembly line. So I go to my server and I right-click and I tell the server that I want to debug it. It means I want to catch assembly lines that open. And I get a blank debugger area. Let's go back to this one, and it's about to call, and this could be TIM initiating an assembly line, it could be some other process, or even a scheduler initiating this assembly line to run. If we step past this call, this assembly line goes into wait mode, because by default it's going to wait for the other assembly line to complete. But now I have my 0-1 test here. I can step through that if I want to. So that's how you debug an assembly line coming from that's being started someplace else, for example, a TIM adapter assembly line.
Well, just point out that TIM adapters don't necessarily always work that way because it's run in a different way. So don't expect to debug TIM this way.
Okay. Okay, I thought that was pretty much most of the time. All right. And that's really, like I said, that's really the debugger here in a nutshell. You can start from scratch. You can tell it to run to a certain point. And once you're inside the debugger, you have full control via this JavaScript command line.
So do it again, Eddie, the conditional breakpoint from scratch, very, very simple, and do it slow, and say you want to stop whenever something in your input is whatever. Okay, and very, very slow now, so everybody will get it.
Okay, I'm going to go to this connector here, and I'm trying to open up the conditional breakpoint. But it looks like it's only going to work here when I'm in a script. So here I'm in a script, and I can set a breakpoint condition, but I'm not sure I can set one here for a, no, I can set that only for my scripts. So at this point, for this script, I can set a breakpoint condition and say that work.getString full name starts with J, or an A, for example. And this will return true or false. And when this one is true, it will stop at the breakpoint, which I also have to enable. So I run it once, and I found nobody. But let me just go back up here and look at my results. And I've got somebody here with a J, so I'll go back there and make that a J. We'll just fudge the demo to fit the data. So now I've stopped. I have control again. I can see that because my step buttons are now active. I'm at this point, and the person I have now is Jose. And to get rid of that condition, I simply have to delete what's in the conditional breakpoint. And then the decoration disappears from here as well. And this is any JavaScript expression which returns true or returns false. Oh, to let you know also, we also have these buttons here which allow you to step to this point. So another way of saying I want to run until I get to the Buffalo lookup would be to hit this. And now it steps to my Buffalo lookup. And the same would be true here for my output. If I wanted to step to the point where I actually do have output, I can step here. And now we're in the output connector. We start stepping into this. Oh, this is after the output done.
So do a quick little show and tell on JavaScript debugging as well, for those that have step 1.
Okay, you mean stepping into JavaScript. Okay, so we'll go to this point here again. Or I think I'll go to my output map and go to an attribute. And again, we'll do that one more time. We'll step here to the mail attribute. And then step into it. And I didn't quite stop where I wanted it to. Let me just restart this one and do it again. Oh, that's my input map. Sorry. I obviously haven't had enough coffee yet. So now we're in our output map. That's where I wanted to be. Then I can step into the script itself. And one of the things that you'll notice about the step into and step over, if I have an if branch, let me just show you that because it's easier to show you. Let me add an if branch to my output map here. If true, ask log message. It's true. And then we'll run again to this point. I can also set breakpoints in my scripts. Let's just run to this point first. And then step into the output map. And then to my mail attribute. Now, if I use step into, I can also step into if branches. If I want to step over an if branch, I use step over. So now it's printed, it's true, but I didn't have to step through the if branch. And the same thing is true if I'm calling a scripted function. I can step into the call or I can step over the call. And if I want to set a breakpoint someplace, I can simply right-click here out in the margin and toggle a breakpoint. So I can set a breakpoint here. I can also double-click to put a breakpoint. And, of course, I can say run to this point in the script. So if we do that, we're now back here again. And each time we do a continue.
So when does it update the watch list when you're walking through JavaScript like that?
With every step. The watch list is only updated every time we step. I'm going to remove the breakpoint because I can see here from the little one in parentheses that I have a one breakpoint inside the script itself. Now we're stopping at that script. And it's important, like Johan was saying, that if you make a change, if I say, for example, I equals 42, I will not have a global variable I showing up here yet. As soon as I make a step, then I do. Then I can see my global variables as well. If I have local variables inside a script function, they're also available and visible, as long as I'm within the scope of that function body. Okay, was there something else, Johan, that you felt that I've skipped over?
No, that was just my initial things. What about people on the call? Any questions, any things you want to see again, or any things you wonder how can be done? Just pipe on up here.
Yes, I had a question on the difference between debugging an assembly line and putting the full server into debug mode, which you were demonstrating a little bit ago in terms of you were talking about doing it potentially with a TIM assembly line. Just, I guess, remote debugging, I guess, is maybe putting a server into debug mode, and just any differences there that you may be able to help me understand some of the remote debugging capabilities, and when you would put a server into debug mode as opposed to, trying to just debug an assembly line directly like this.
Okay. Well, what you're doing, what you want to do, what the end goal is to get the debugger open with that assembly line. So you use the same technique that you would debugging a local assembly line. Well, what I did was that prior to that assembly line being started on that server, I right-clicked and said debug server, which gave me an empty. Now I have an empty debugger. So if we start my assembly line, which is called db.xml, if I just run that should have the same effect. No, that does not have the same effect. Not at all. So what I need to do then is if I'm going to test this myself, I start the assembly line from one assembly line. So I launch my debugger, I step down to the point where I start the assembly line, and then I catch it here as soon as it's started. In the case of TIM, I have to wait here now. Now I'd bring up my TIM interface, and I do a provisioning operation. And then when TIM goes out and dispatches the assembly line and tells it to run on that server,
Eddie, unless you're certain, don't go down that path, because Tim uses an old internal interface and not the normal TDI API, so it might not work at all.
Okay, I thought that the Tim development team themselves were using this, or the test team. Okay. I'll tell you what, this will be a great place to give feedback to the news group when you get home and you test this, and you find out some things are working differently or not quite like they should be or not at all. Then you drop a note in the forum. We scan the forum daily.
Okay. So I guess a follow-up question would be, remotely debugging on a server, how do you determine, there could be multiple assembly lines being kicked off, right, and multiple named assembly lines. I'm assuming multiple assembly lines could be running at the same time. Is there a way to, in a development environment, if you're just trying to, like you said, kick off one assembly line and wait for that, that may be pretty straightforward. But what about multiple assembly lines being run on a server in that situation, and how would you potentially connect to, any one given assembly line? Or is
it makes sense, but to desire that, but we haven't implemented anything particular to deal with that kind of complex environment. So if you want to run this in an environment with a lot of stuff going, it's going to fire up debuggers, for all of your assembly lines, which is not all to do.
So it'll fire up individual debuggers for each one that kicks off. I'm just curious what the behavior is, not necessarily.
You'll get a tab here. You'll get a tab for every assembly line that it catches, and it doesn't. You can't connect to an assembly line that's already running. It's when an assembly line starts, it gives a signal back to the CE, and we get a new tab here with that assembly line.
Okay. That's kind of more I wanted to understand what the behavior would be. So thank you.
Okay. Good. More questions? I hope I haven't stumbled through this too quickly, because I want you guys to really try this out, because this is a tool which can make a big difference in your life when you're developing and building and working on TDI solutions. And it really lets you get under the covers or under the hood of TDI and see exactly what's going on. Those of you who haven't seen them, in the online documentation, we have the hook flow diagrams. So I'm going to have to get up here and bring it across. So here in the online help for TDI, under the reference guide, and note that all the guides have a PDF version link, so I can just right-click and save this to my hard disk, so I don't have to be online to get the documentation. We also have the flow diagrams, and the flow diagrams are just a simple diagramming of what happens. These are the hooks and the internal operations that happen. So this page here that I'm showing you is what happens for an assembly line every time it runs, regardless of what that assembly line is doing. And if I step down here to connector modes, we've got add-only mode. And these are all the hooks that you'll see. There's the output map. There's also a scripting point. But these are the hooks that you'll see if you go to the hooks tab of the connector. And as you step through it, you can actually verify that it's making this trip through these flows every time. This is also a very handy document to have on your machine. Okay, questions?
Okay, well, we're 7 minutes off our hour, which is a good start. We'll feel free to create YouTube snippets. If you can use a tool like Jing, or if you've got Max or other tool to record something on your PC, create a link on YouTube and then link to that from the forum. And if you want help on something and you want to see things in action, it's a great way to share questions rather than just trying to describe it in text. And so we can follow up the conversation around this on the forum. And we'll also in the next session, if there are issues that have come up that needs a little bit more of a common demo, we'll spend some time of the call, digging further into those pieces in the debugger. So with that, send me an email on feedback on the format, on the content, on the improvements, on other stuff, and I'll send you all a list with the upcoming Wednesdays, probably spaced a month apart, and hope to see you online then. So thanks for the call, everybody, and thanks for participating.
Thank you. It was very good. Thank you.
Thank you.
Thank you, guys.